Switching, a layer 2 device that uses MAC addresses to forward frames between devices on the same network. Switch versus hubs, like you see here, hub and switch. Data transmission. Hubs sends data to all devices, but switch sends data only to the intended device. Speed, slower, more collisions. More collisions. Switch faster, less congestion. Efficiency, less efficient hubs, but switch more efficient. Layer works at layer 1, which is physical layer, in OSI model layer. Switch works at layer 2, data link layer, in actually OSI model. MAC address table. How it works. 1. Learning. Record source MACs and ports. 2. Forwarding. Sends frames to the correct port. 3. Floating. If MAC is unknown, broadcast to all ports except source. MAC table example. Something like that. Fun fact, MAC addresses are burned into NICs like a network fingerprint. NIC exactly your network interface card. Okay. MAC address versus MAC address table. MAC address a unique identifier assigned to a device's network interface, like a laptop or phone. Think of it like a home address. It tells the network where a device is. MAC address tables, a list stored inside a switch that maps MAC address to specific ports. Think of it like a delivery system. It helps the switch know where to send data efficiently. How they work together. A device sends data. The switch learns its MAC address and stores it in the table. 2. Another device wants to send data. The switch checks the table and forwards it to the correct port. 3. If the MAC address isn't in the table, the switch broadcasts the data to find the right device. VLANs concept. Virtual LANs segment traffic logically, even on the same physical switch. VLAN types. First one, voice VLAN, which is something like that. A dedicated VLAN for VoIP traffic that prioritizes voice calls to ensure clear quality. It spreads phone traffic from regular data to prevent delays and distributions. Another one, default VLAN. The Intel VLAN, usually VLAN 1, where all switch ports start before configuration. For security, avoiding using it for user traffic and assign a different management VLAN. Last one, native VLAN handles untagged traffic on trunk ports, default VLAN 1. To prevent security risk, set it to an unused VLAN and never pass user data through it. Creative scenario. Imagine VLANs as subway lines. Passengers, which is buckets, on the red line, VLAN 10, never interact with the blue line, VLAN 20, writes. Spanning Tree Protocol, STP. Why STP? Prevents both broadcast storms caused by redundant links. STP port rules. 1. Root port. The best path to the root bridge chosen on every non-root switch. Number 2. Designated port. The port on a segment with the best path to the root forwards traffic. Number 3. Blocking port. A port that blocks traffic to prevent loops. Alternate paths are disabled. Okay. Let's dive deeper into it. Why we need STP? Imagine routes in a city. If there are multiple paths to the same destination, cars might go in circle, causing traffic jams. In networks, this happens when switches create loops leading to broadcast drums, endless data flooding. How does STP fix this? STP blocks extra paths to prevent loops, ensuring data flows smoothly. If a main path fails, STP activates a backup route, keeping the network running. Simple analogy. Think of STP like a traffic lights. It stops unnecessary movement but allows backup routes when needed. Okay, STP. Advanced switching. Switching methods. Switching methods refer to changing techniques or approaches during a task to improve efficiency or adapt to new conditions. Common examples include time-based switching, like Pomodoro technique, or basic text switching, like alternating between different activities. The goal is to optimize productivity, reduce fatigue, or handle multiple tasks effectively. Security features: 1. Port security. Restrict max per port. 2. DHCP snooping. Block to DHCP servers. Dynamic ARP inspections. Stop ARP spoofing.